Welcome back to the second part of velocity and acceleration lesson. So far we discussed the formulas for velocity as the first derivative of position and acceleration as the first derivative of velocity or second derivative of position. Now we are going to move on to analyzing the motion of an object based on the graph. The graph that you see represents a relationship between position and time. And the red line describes the motion of a bicycle. So we have to find the velocity and acceleration, and we have to describe the graph and what it means to the motion of the bicycle based on the shape of it. So we're going to look at specific intervals as we go over analyzing the whole motion. So we're going to start from point A to B. From point A to B, as you can see, the position at any point will be 0. Again, remember that this graph describes the relationship between position and time. So if the position is 0 at all times, it means that the object is not moving. So we'll say that slope equals 0 because it's a horizontal segment and the object is not moving. That means that the velocity is 0 and so is the acceleration. For the second portion of the graph, from point B to point C, we see that the slope of the tangent at any point is positive. That means that the function is increasing, or that means that position is increasing. So we'll write slope is positive. And if you look at the slope at the beginning of the motion, say close to point B, and the slope at point C, you will see that the slope is increasing in value. Remember that the slope of the tangent measures the rate of change of position, and the rate of change of position measures velocity. So we'll say that velocity is positive. And velocity is increasing in value. So if velocity is increasing, that means that the rate of change of velocity is positive, or in other words, acceleration is positive. So I'll write down here, because velocity is increasing. The next time interval we're looking at is from point C to point D. So as you can see, from point C to point D, the slope of the tangent at any point is positive. So we'll say slope is positive. And a positive slope means that velocity is positive. Now, when you look at the slope of the tangent, starting from the beginning of the interval, which is C, going towards the end of the interval at D, you see that the slope goes from positive to 0 at D, which means that the slope is decreasing. So I'm going to write it here a bit. Which means that velocity is decreasing. And the decreasing velocity means that the rate of change of velocity, or we should say acceleration, is negative. So even though the velocity is positive, the acceleration is decreasing. Okay, and that's very important to point out. Now, the next interval is at D. So we are going to talk at what happens exactly at this very moment. At D, the slope is 0. So what that means is that the object has momentarily stopped. Which means, on the other hand, that velocity is 0 because the object is not moving. Now, how about acceleration? We have to think very carefully here. At the point D, even though the position is not changing, which makes the velocity 0, we still say that the velocity is continuing to follow the same pattern as it had before. So the pattern that it had before is a decreasing pattern of velocity because the slope continues to decrease in here. So we'll say that at the point D, the acceleration will be negative because velocity is decreasing. So it is still following the decreasing pattern that has started in the previous interval. Okay? Now, from point D to point E, which is our next interval, we're going to say that the slope of the tangent is negative. Now, let's take a look at negative, but what is the pattern? Is it becoming more negative or less negative? So you start at the slope 0, which is at D, and then after that, negative, more negative, more negative. So we'll say that it is negative and decreasing. Which means that the rate of change of position is negative. Or velocity is negative. And because velocity is also decreasing, we'll say that the acceleration is negative because the rate of change of velocity is negative. So it's negative, but it is also becoming even more negative. Is decreasing or becoming even more negative. The next interval is from E to F. And from E to F, you can see again that the slope is still negative. Now let's take a look at the pattern on the value of the slope. So very negative, less negative, less negative until it hits point F, where it's 0, which tells us that slope is negative and increasing in the meantime. So still a negative number, but becoming less negative, and that's an increase. So that tells us that from E to F, the velocity is negative. And because velocity is becoming less and less negative as we move towards point F, we'll say that the acceleration is positive. Again, because velocity is increasing, which is marked by it being less negative. And from point F to G, as you can see here, the position remains constant. So the object will be at this particular distance from the starting point, okay? And this distance is not changing. So we'll say that slope is 0. It's a horizontal segment. When slope is 0 means that the rate of change of position is 0 or velocity is 0. And velocity remains 0 for the whole interval, which means that velocity didn't change for the whole interval, and that makes the acceleration equal to 0 as well. Now, looking at this graph, I want us to also think a little bit differently. So if the object is going from point A to point B, the object is not moving, so is right at the starting point. So try to imagine this situation in real life. So for these first 2 seconds, we'll say that, pretend that this is 1 second for each, right? So the object has not changed position. That means that the object is still at home. And then the object starts changing the position, and it starts to go away from the initial point. So it starts with a smaller speed, but then the speed is increasing. In this case, we say that the object is speeding up. The speed is still positive, right, beyond point C, but it starts decreasing. When the speed is decreasing, we'll say that the object is slowing down. Okay, so no motion. Let's mark them. Okay, so moving away from the starting point, because the position or the object, as you can see, is getting away from home, and the object is also speeding up, because the velocity from 0 becomes more and more and more and more positive. Now from C to D, the object is still moving away, from the initial point. You can see this is the starting point, and this is consistently increasing. The position is consistently increasing, which means that the object is moving away from the starting point. Now velocity is positive, so it's following up with position, but it is slowing down because it's very positive and then less positive. So we say slowing down. Now, at point D, momentarily stopped. From point D to point E, you can tell that the position or the object is getting closer to the starting point because the position is decreasing, right? So the position is still measured with a positive number here, right? Because we are on the positive values of S. But the velocity is negative, all right? Because the slope of the tangent is negative. We say that the object is going towards the starting point. Now, how is the object moving? Well, here the velocity was 0, and then the velocity kept on becoming more and more negative. Remember, what makes velocity negative is the direction, but the actual object is moving faster. So we say that the object is speeding up here. And then from point E to point F, the object is still moving towards the initial point or the starting point because the position is decreasing. So from this position here, it becomes this one, all right? So the position is getting smaller. So the object is moving towards the starting point. The position is still measured by positive numbers, but velocity is negative. In the meantime, we'll say that the velocity went from very negative to less negative. So we said that in this case, from point E to F, the acceleration is positive, all right? But you can tell that the position is not changing as fast, so it is slowing down. And from F to G, position is not changing, velocity is not changing, and obviously the acceleration is zero as well. So velocity is zero and acceleration is zero because position hasn't changed for the whole interval. So the object has come to a stop. So the reason I wanted to bring this graph analysis to creating a picture of a real life, how the motion has actually happened, is because in the next part of the lesson, we want to talk about how to determine whether an object is moving towards or away from the initial point, and how to determine whether the object is speeding up or slowing down. Thank you for listening.